How's it going? I hope you're well. This video is going to be a little long form, a little diffuse, and for that reason I want to start things off by discussing what we're going to get and why it might be important. macOS Metal is a really good API. I like it. It's a good sweet spot between complexity and usability. But what I really do not like, and I've been very vocal about this, is the lack of support for game development in Mac. Like, I can open up Xcode, I can make an app, and if my app is a to-do list, then I can program it no problem. But if my app is a game, it's for some reason this unconquerable black art to detect a key press or a mouse movement or something. It's a nightmare. It's too much. So in addition to that, I would really like to have a simple C++ project running on cmake where I can, whatever system I run it on, it can detect what that system is and employ the appropriate rendering backend, basically. So I can have, if Mac had OpenGL, then I could just use OpenGL for everything, but it doesn't. But Mac has Metal, and Metal has storage buffers, and it's roughly equivalent to OpenGL, give or take a little bit. It's fine, I'm fine with that. So that was even worse than this video is going to be in terms of diffuseness, but the basic idea is I'm going to be working in VS Code in C++, and a little bit of Objective-C++, and we're going to get just a really minimal window up with some coloring, but with GLFW. Okay, so with that out of the way, what we're going to need in order to do this is, if I just open up, see if I can find it. Okay, here there's this folder called Metal CPP, and what this has is all of these libraries are basically Objective-C. They're frameworks. They're frameworks which are meant to be called from Objective-C, but Apple has provided a bunch of these C++ headers which adapt the Objective-C code, and that basically lets us use all of this stuff. So what I'm going to do is I'm going to grab everything in here, copy it, and by the way, if you're not sure how to get it, what we can do is just open up any search engine and search for Metal CPP. We have this thing here, getting started with Metal CPP, awesome, and hopefully they've got a bunch of downloads. But anyway, so I've just got some previous version downloaded from some point in time, and I'll just go ahead and make a new folder, which I'll call it Metal CPP minimal or something. Here we go, open that up. I'll make a new folder. Yeah, dependencies. Inside dependencies, I'll paste all of this stuff. License and readme, probably don't need that. Single header is just a Python script which will boil all of this down into one header, but I'm not going to use that, so I'll get rid of all this stuff. So again, AppKit, Foundation, Metal, MetalKit, Quartz Core, all of those things. And I'm also going to go to the Vulkan video that I did before, grab the GLFW headers and paste those in. But there's nothing too exciting about these GLFW headers. They are literally just the standard GLFW3 and GLFW3 native. So just the usual stuff. So I'll also make a source folder. That's where my source code will go. And that'll probably be it for now. Okay, so I'll open up Visual Studio Code and I will open my folder of interest. So what I'm going to do is I'll just go into my source folder and make a main. This is really just a proof of concept, and for that reason I'm not going to worry with any abstractions really. I'm just going to do the whole thing in one file. Let me just go ahead and put that in just as a placeholder, and then I'll make my my cmake lists.txt, and on with the show. So the first thing I'll do is I'll set my minimum version. And declare my project. I'll also go ahead and set the language standard. Why not? This is really a holdover from my previous video. Then I'll go ahead and add that main file to my executable. So this should be fine for now. We can go ahead, and I know that we can't see this, but up the top, I'm clicking on the View item of the menu, and then it's View Command Palette, just like this. Okay, then I click cmake, delete cache, and reconfigure. I'll select clang. We can see here that it's gone ahead and given me those build files. Now just down the bottom, I can hit run, and it compiles and runs it and pretty much does nothing. Okay, great. So what I'm going to do now is I'm going to head back to my main file, and I'm going to include these things, these extra library files. So if you've done any work with Metal CPP before, you'll know that there's a bunch of definitions which actually have to happen. But let's just take this one step at a time. So what I'll do, now as you'll see here, this project doesn't really know about that dependencies folder, no problem. This is what I started to type before, but then I thought, hey, let's do it as it comes up. So let's do that now. What I'll do is I will say, yeah, include that directory. Okay, and now if I go back, you can see that we've got it, no problem. This bit is going to be very similar to STB image. If you're familiar with that, you know that you need to have one source file where you've declared that this is the single point at which everything is going to be defined, the implementation point. This is a thing with single header libraries, and I'm going to do something very similar. So what I'll do is I'll define next step. So if you're familiar with Metal CPP, you know that these three lines need to be included in order to use the headers. So core animation and metal. Now what I'm going to do is I'm going to go ahead and grab a few of these headers and just bring them in. Okay, I think that'll be fine for now. With that stuff, first thing I'm going to do is build a GLFW window. Now this goes pretty much the same as you would expect. So there we have it, that's the standard GLFW initialization. We give the window size, window title, the thing to share resources with, the primary monitor, something like that. Awesome. We can also go ahead and get our metal device. So I'll say, alrighty, in the metal namespace, I want to get a device. There we go, system default device. And it's a good idea just to periodically run this and see, you know, that we're getting what we expect. So we can go ahead and click run, and we get a bunch of errors. And you can probably tell me what the errors are, right? Because I've started using a bunch of libraries so we can see the headers, so no problem. But as you know, in order to actually call the libraries, those libraries need to be found and linked. So what I'll do is I'll head over to my cmake, and now here's how we find those libraries. This is a little funky, to be honest. I just searched this up online, I saw it, it works, so I'll keep it. And then what I'm going to do is go ahead and link those libraries. Okay. Haha, whoops, psych. So here what we're doing is we're going through, we're saying, all right, these are the frameworks which we are going to be including, and the system will go ahead and search for those. I'm also going to link GLFW. So in theory, we could start doing tests on the underlying system to see which operating system they're running, and then set the appropriate defines and include the appropriate frameworks. People are cringing now. There we go. Okay, so we've got everything. Let's give it a go, see if it's found those frameworks. It appears to have found those frameworks. There we go, we've got our basic loop set up. We've got our window, awesome. We close it, we're done. So far we've not done any metal stuff though, apart from the device, I guess. So what I'm going to do is I'm going to now create what's called a layer. So I have this core animation metal layer. So I'll go ahead and call this method. This returns the metal layer, or a metal layer. And then I'll go ahead, and you'll see this pattern a lot, is I'll retain this. And what this does is it increments the manual memory count on that object. So then we can go release, and that will decrement the reference count. Gonna need to set a few things, so I'll say set device, and I'll set the pixel format. Okay, so now what I've got is I've got a GLFW window, but I want to sort of get a native Cocoa window from this. And additionally, what I want to do is I want to configure that Cocoa window so that when I basically so that it renders this layer. So when I do any work on this layer, that will be drawn to the Cocoa window. It's a funny name, Cocoa window. But anyway, the problem here is I want to do something like this. I want to go up above, for instance, and we're finally going to use it. Okay, so think of GLFW3 or GLFW as like a really high-level library, which doesn't really, in terms of the interface, it doesn't really matter so much what the operating system is. But then we have GLFW3 native, and what it can do is it can give us actual native handles to the windows that it created. So this native really cares about the operating system that we're running this on. What I would want to do is I would want to go down here and say GLFW get Cocoa window, and then I'll pass in my GLFW window. But the strange thing is that this returns what's called an ID. And an ID is sort of a little bit, I'll think of it as sort of a little bit like an Objective-C version of a pointer. Okay, so it returns an NS window, and this NS window is an Objective-C object, right? We can have the window, or we can also have null, just the same way, you know, that Swift or other programming languages have nullable pointers, optional pointers. But then what I want to do is I really want to get this into a C++ version. So think of it as this function basically returns Objective-C objects, but I want to corral them into C++ objects. Probably the most elegant way that I've found to do this is to create what's called an adapter. So I can go to my source and make a backend folder, and inside there I'm going to make a GLFW adapter header file and a GLFW adapter Objective-C++ file. So that's a .mm extension on the end there. Okay, so I'll get rid of this. I'll actually put it in here. So this is in my header. So here's what I'm going to do. I want some sort of function which returns a next step window. And in order to do that, it's going to take in the GLFW window pointer, as well as the, as well as the metal layer, because it's going to not just return the window, but it's also going to bind that metal layer to the window. Cool. So I'll go over to the Objective-C++ file and define this. For whatever reason, I just can't get autocomplete working. This is one of those situations, you know, the universe is really pushing me and saying, hey, use Xcode, use Xcode. And I'm like, no, I'd rather not. So this is an interesting construct here on line 4. What this is doing is this is taking in this C++ pointer, and it's doing what's called a bridging cast. So it's, think of it as simply casting this over to an Objective-C pointer. And the same thing here. So this getCocoa window is going to return an Objective-C ID, but this will sort of unwrap that and cast it into an Objective-C next step window object. Because what I'm going to do is I'm going to modify the Objective-C window. So again, I'm going to cast back the other way. So now I'm going to go and cast to a standard C++ pointer. And return that. But with that out of the way, all we really need to do is go over and include this in our project. Psych, there we go, it's working now. And then we'll go to our main and just down here, we'll use that. have to include it, of course. Now, just as before, this is going to give us a pointer, and I'm going to increment the pointer count with the retain operation and release it just like that. And there we have it. So we're almost done. It's probably a good idea to run this and verify that it is working. Nice. Okay. Now, again, the goal for this video is to get a solid color sort of cleared up on this screen. In order to do that, I'm going to need a few things. I'm going to have a core animation metal drawable area. I'm also going to have a command queue. So now we're going to get into the main loop. So with a lot of metal stuff, you see we're doing this like retain, release sort of stuff. It's a little strange. So what I'm going to do is I'm going to make, especially for these sections where a lot of objects are sort of flying around, I'm going to create an auto release pool. And what this will do is basically any manual memory objects which are created within the scope of this pool will automatically be retained by the pool. So when the pool gets released, everything else does as well. Okay, so first up, I'll get my drawable area, and I can do that by querying my metal layer. I'll then create a command buffer. So here I'm going through the fun stuff of setting up the render pass, which will be used on that command buffer. As you've seen probably many times, the render pass is really just going to clear the screen and do nothing else at this stage. So we are now ready to start a render pass. So let's go ahead and make a render command encoder. Just like that. So, and it works. And that's a very garish red, but there we go. It's working. Cool. So again, this is just a really like proof of concept, mostly all in one file, no abstractions, very minimal, just get on the ground, get going. But hopefully you can see some of the benefits of this approach as part of a larger project. We get it all in unified. What am I saying? It's cmake. I like cmake, especially recently. Anyway, so that'll be it for today. I hope you enjoy this, and I will see you again soon. Bye.